go to page 47 in your journal and get these 3 definitions. Now take a look at the core concepts for solving quadratic equations. We can see here that we have 3 methods. 1 is by graphing, 2 is using square roots, and 3 is by factoring. I'm going to take notes on each of these sections, and I want you to write these down in your journal. So, by graphing, we always want to have the equation equal to 0. And you'll see what I mean by that when we do an example. Then, we want to plug it into y equals on the calculator. And the third thing we want to do is hit the second calc button. It's the trace button at the top. And then you're going to go to number 2, which is 0, and push enter. Then the graph will come up on your calculator, and you have to go to the left of the point, push enter, to the right of the point, push enter, and then enter one more time. And you'll repeat this for the second 0 if there are 2 zeros. And remember, a 0 is just an x-intercept, right? So we're looking for the x-intercepts. The next thing we can do is use square roots to solve the problem. This is when you have an equation and there's no bx term. So you know how we have ax squared plus bx plus c? This is when there's no bx term, so b is 0. The first part is going to be get the squared, so x squared part all by itself. The second part is going to be take the square root of each side and make sure you add plus or minus in front of that. And the last step will be to solve. The third way to solve for zeros is going to be factoring. For this, you want the equation to be set equal to 0. Then you want to factor it. And then solve for x by setting each factor equal to 0. And solve for x. Now let's go to your notes packet and do example 1. Example 1 asks us to solve by graphing. So we want to make sure our equation is equal to 0. We have that for the first one, part A. And then we want to enter this into our y equals of our calculator. And if you go to Desmos.com, you can see here I entered my equation, x squared minus x minus 6, and here's my graph. We're looking for the x-intercepts. So if you see when I hover my mouse over it, I see 3, 0 and negative 2, 0. If we were in the calculator, I'll show you how to do this tomorrow, but whenever it's a nice number like this, we don't really have to do the whole second calculate. We only have to do that when it's a decimal or it's hard to find. So looking back at the notes, I'm going to say my zeros are x equals 3 and x equals negative 2. And then I'm going to graph by plotting 3 and negative 2. And I'm not really concerned about the other points. I just want to make sure that my curve is happy. It's going up and it goes through 3 and negative 2. Now I want to take a look at example 2. So I've got my answers for example 1. In example 2, this is not equal to 0, looking at this equation. So I need to subtract 4x from both sides so that I get negative 2x squared minus 4x minus 2 equals 0. So when I do that, I'm going to now plug this equation into my y equals, or plug it into Desmos. As you can see here, when I plug the function into Desmos, I see that my x-intercept is -1, and there's no other x-intercepts. So going back to my notes, I'm going to write x equals -1, plot that point on my graph, and sketch the curve. Make sure it's going down. Now skip the monitoring progress, we'll do those in class tomorrow, and take a look at example 2. We want to solve now using square roots. So we want the x squared term to be all by itself. So I'm going to add 31 to both sides. So I'll get 4x squared equals 80. Then I divide both sides by 4 to get x squared equals 20. And now I'll take the square root of both sides, but when I do that, I have to add the plus or minus square root of 20. Because remember, 5 squared and -5 squared are both going to equal a positive number. So we have to say plus or minus the square root of 20. And then we can reduce this. So if you remember your square roots, we can say this is the same thing as plus or minus 2 square root 5. And there's our final answer. Looking at part B, we want to get the x squared term all by itself, so I subtract 9 from both sides. And I can divide by 3. And I see here that x squared equals -3. Well, we know that when you square a number, it becomes positive, so the answer here is going to be no real solutions. So if you ever get an x squared equal to a negative number, for now we're going to say there's no real solutions, and you're going to move on to the next problem. For part C, we start by multiplying both sides by 5/2 to get rid of that fraction. And I'm going to keep this like a fraction, 25/2. It makes things a little bit easier for simplifying. So if I take the square root of both sides now, I'm going to get x plus 3 equals plus or minus the square root of 25/2. Now I want to subtract 3 from both sides, so I'm going to say x equals -3 plus or minus the square root of 25/2. Now you can reduce this and simplify because the square root of 25 is 5. So I could say x equals -3 plus or minus 5 over the square root of 2. And the book in Big Ideas will write a rational, they'll rationalize this. So you would say -3 plus or minus 5 square root 2 over 2. If you don't remember to rationalize the denominator, for now we're not going to take points off, so you could leave this as your final answer here.